Hey guys, this set of notes is probably going to be longer than some of the rest, but we're going to be studying lesson 9-4, and we're going to be talking about changes in dimensions. And basically, how does that affect the perimeter and the area? So, changes in dimensions. Come on, E. Sorry, there's a little tab here that gets in the way of me writing sometimes. Changes in dimensions. Let's say with perimeter and area. And we'll write the date as 4/9/19. Okay. So we're going to kind of do some exploration, inquiry, so to speak. And you notice I have a graph paper here so I can draw things a little bit neater. So we're going to start with a situation where we're going to draw two rectangles. The second rectangle has dimensions that are twice the size of the first rectangle. If you can hear that, that's Sophie coming to join us. Go away, Goofy. So we're going to label the dimensions. And when I use the word dimensions, I am talking about length and width. On both rectangles. And then we're going to find the perimeter and area of each rectangle. Okay, so I'm going to actually draw my two rectangles. One is going to be a 3x6, so 1, 2, 3, 1, 2, 3, 4, 5, 6. And we're going to say that each of these squares is an inch. So this is a 3-inch by 1, 2, 3, 4, 5, 6. Make sure that's right. 6-inch. So this is our first one. Now the second one is going to have dimensions that are twice the size. So for example, twice 6 is going to be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And twice 3 is going to be 6. 2, 3, 4, 5, 6. So his dimensions are going to be 6 inches by 12 inches. Okay? So what we're going to do is figure out the perimeter for the first guy, and we're going to figure out the area for the first guy, and then we're going to do the same thing for the second guy. So let's start with perimeter. So perimeter of this first one, let's see, we're going to take 2 times the length, which is 6, times 2 times the width, which is 3. So I get 12 plus 6 equals 18 inches. Okay? Let's figure out what its area is. So area is going to be the length times the width, or base times the height. So we get 6 times 3, and that gives me 18 square inches. So in your mind for right now, I just want you to think to yourself, what do you think is going to happen when I double the dimensions, so in figure 2, what do you think is going to happen to the perimeter? Okay, so you got that idea in your mind. Let's see what happens. So we're going to have 2 times 12 plus 2 times 6. And we get 24 plus 12, which equals 36 inches. Okay. That's interesting. And then let's look at the area. We're going to have base times height, and we're going to get 72 square inches. All right, so what I'd like to do is to figure out the ratio of the perimeters and then look at the ratio of the areas. So let's do that off to the side. Ratio of perimeters. And by the way, these notes should take 2 pages, just to let you know. So we're going to take the perimeter of the large one over the perimeter of the small one. So the perimeter of the large one was 36 inches, and the small one was 18 inches. Now, the labels cancel out, and then we just go ahead and reduce to lowest terms. And actually, they both have an 18 in common, so we end up with 2 to 1. So another way of saying this would be that the perimeter of the larger rectangle is going to be twice the perimeter of the smaller rectangle. Okay? You think that relationship is going to hold true with the ratio of the areas? I don't know. Let's test it out. So again, we're going to compare the larger one to the smaller one. And see, in the larger area was 72 square inches. The smaller area was 18 square inches. The labels cancel out. And see, 18 goes into itself once and into 72 4 times. So we get 4 to 1. So what we can say is that the perimeter, or the area of the larger shape is actually 4 times the area of the smaller shape. Okay, very interesting. Okay, so I'm going to write down a couple of things just as reminders. If I hear the word twice, because you'll hear that the dimensions are twice the size, that means that we multiply by 2. Okay. And then if we noticed that when it came to the perimeter, we had twice the small perimeter. Will equal the large perimeter. So we're just kind of like rewriting those ideas that we just saw. Okay. And with the area, we said we're going to multiply the small area area by 4 to equal the large area. Now, this is only true because we are doubling the dimensions. So again, in a pithy way, when we double dimensions, this is the impact that it has. So we take our small perimeter, we multiply it by 2, we get our large perimeter. Okay? We take our small area, multiply it by 4, and it equals the large area. Now, you might say, well, why is the area multiplied by 4 and not by 2? Well, think about it. Each dimension is multiplied by 2. So multiplying by 2 and multiplying by 2 is the same thing as multiplying by 4. So let's go through, now that we have this understanding, what if we decide we're going to triple the dimensions? Excuse me, so I'm going to go to my next page, and let's go through that. So the directions say triple the dimensions of a rectangle Oh, this thing is annoying, sorry. Alright, I'm going to redo this and go down a line because it doesn't seem to like me. Boo hiss. Triple the dimensions of a rectangle to create a larger rectangle. Okay, we're going to calculate the perimeter and area of each shape. And then we want to know what happens to the second rectangle's perimeter and area compared to the first rectangles. Perimeter and area. So I'm going to abbreviate with P and A for that. So let's come up with a thought. What do we think is going to happen? So let's think about it. So when we doubled, we took the second perimeter, the larger one, was going to be double the first perimeter. And then the area of the second one was 4 times the area of the first one. Okay, so keeping that in mind, what do you think we might be doing when it comes to our shape, tripling? So this is what we're going to call a conjecture. So in science, you talk about conjecture. It's kind of a guess what you think is going to happen. So let's think. If when I doubled, I multiplied the perimeter by 2. So when I triple, do you think maybe the bigger perimeter would be 3 times the smaller perimeter? Okay. Now let's see. Since each side was doubled, we ended up multiplying the area by 4 because it was times 2 times 2. So if each dimension is tripled, would we multiply by 3 or by 9? So the second area would be 9 times the first area. All right, so let's draw this out. I'm going to start with a 1 by 2. Oh, really teeny. There's my 2. There's my 1. Actually, let's go the other way. I don't like the way that looks. Let's go the other direction. So make it this way. So this is our first shape, and it's a 1 inch by 2 inch. So if I triple 1, I'm going to get 3. And if I triple 2, I'm going to get 6. 1, 2, 3, 4, 5, 6. So 1 tripled is 3 inches. 2 tripled is going to be 6 inches. Okay, so we're going to go do what we did before. We're going to figure out the perimeter of each, and then we're going to compare them and see if our conjecture is correct or incorrect. So let's go with this guy for perimeter of the first. Let's see, we have 2 times the length plus 2 times the width. 2 times 2 plus 2 times 1. So I get 4 plus 2, and that gives me 6 inches. Its area is going to be length times width, or 2 squared inches. All right, let's look at this next guy. Perimeter of the second one, 2 times the length plus 2 times the width is going to give me 12 plus 6, or 18 inches. Ooh. Oh, that's looking interesting. Area, of the second guy is going to be the 6 times the 3, which is going to give me 18 square inches. All right, so let's double check and see what's going on here. So let's start with the perimeter. So we're going to take the big perimeter compared to the smaller perimeter. Oops, try to write it again. There we go. So that's going to be 18 inches to 6 inches. So the inches go away. 6 goes into itself once and into 18 3 times. Aha! Didn't we say that was going to happen? All right, let's try the other guy. Let's do area. Let's see. So the area of the large one versus the area of the small one. We're going to have 18 square inches, and we're going to compare it to 2 square inches. So the square inches go away, 2 goes into itself once, and into 18 9 times. Oh, look at that. Look at that. So guess what? When we did the perimeter, if we took the big perimeter, it would be 3 times the small perimeter. And if we took the large area, it would be 9 times the small area, which is exactly what we thought it would be. So, what happens when we triple? So, when tripling dimensions, this is what happens. We're going to take the smaller perimeter, and if we triple it, then we're going to get the larger perimeter. Also, if we take the large area and we multiply it by 9, which is really 3 times 3 or 3 squared, we get the larger area. And that's how we're going to do this, folks. All right, good luck with this.